The future isn't some distant dream, it's unfolding right now in labs and workshops across the globe. Today's breakthroughs in rockets, robotics, clean energy, and microdrones are reshaping our world at a staggering pace. These aren't just upgrades, they're paradigm shifts, laying the foundation for a world that will look nothing like today's. So, let's break down 10 groundbreaking technologies that are set to change everything. Ready? Let's dive in. Let's start with space. The final frontier, a realm of endless possibilities and mysteries waiting to be unraveled. Our vehicle of choice, the NASA Orion spacecraft. A marvel of engineering, designed to push the boundaries of human exploration. Orion isn't just another capsule, it's a symbol of our ambition to reach beyond Earth's orbit. It's the backbone of the Artemis program, NASA's ambitious endeavor to return humans to the moon and establish a long-term presence there. Designed to take humans back to the moon, paving the way for groundbreaking scientific discoveries and technological advancements. And eventually, Mars, the red planet, our ultimate destination in the quest to become a multiplanetary species. Built for deep space, Orion is equipped to withstand the harsh conditions of interplanetary travel. Orion can handle extreme temperatures and radiation thanks to its advanced heat shield and radiation shielding technologies. And its launch abort system is a high-tech safety net for astronauts, ensuring their survival in case of an emergency during launch. It's not a one-off, this isn't just a single mission, but a series of planned expeditions. Orion is part of a long-term vision, a roadmap for sustained exploration and development beyond Earth, building a sustainable human presence, establishing a permanent foothold in the cosmos. On and around the moon, conducting scientific research, resource utilization, and preparing for even more ambitious journeys, with the Gateway Lunar Station as a stepping stone to Mars, a crucial hub for lunar operations and a staging point for deep space missions. The capsule supports 4 astronauts for up to 21 days, providing a comfortable and safe environment for extended missions. With advanced life support, navigation, and a modern automated cockpit, making space travel safer and more efficient than ever before. This is the vehicle that will carry the next generation of explorers, the pioneers who will venture into the unknown. People who will walk on the moon for the first time in over 50 years, leaving their footprints on a new era of lunar exploration. When you see Orion launch, you're not just witnessing a rocket taking off. You're witnessing the start of a new era in space exploration, a bold step towards a future where humanity is a true spacefaring civilization. It's about building infrastructure in space, creating the foundation for future missions and long-term habitation. Not just planting flags, but establishing a lasting presence and expanding our understanding of the universe. Orion represents a massive investment in our future as a multi-planetary species, securing our place among the stars. It's the hardware that will help us answer some of humanity's biggest questions, unlocking the secrets of the cosmos and our place within it. For tech enthusiasts, it doesn't get much more exciting than this. A showcase of human ingenuity and technological prowess. This is the real deal, the culmination of years of research, development, and testing. Let's see what's next. The future of space exploration is here, and it's brighter than ever. Now back to Earth after our brief cosmic detour. Let's talk humanoid robots. These aren't your clunky science fiction automatons. We're entering an era of incredibly sophisticated machines. Companies like Eon Hexagon and many others around the globe are redefining robotics, pushing the boundaries of what's possible. They're creating machines that move with uncanny human-like precision. It's almost eerie how natural their movements have become. Through biomimicry, engineers have replicated not just walking, but the nuances of human locomotion. They've mastered the subtle shifts in balance, the way we adjust our weight with every step. And they've even captured the dexterity of human hands, a feat of engineering in itself. These robots can perform delicate tasks that require a level of precision previously unattainable by machines. They're capable of picking up small objects, handling them with care and accuracy. They can even operate tools, adapting to different shapes and sizes with ease. All of this is powered by advanced sensors and AI, allowing them to perceive and react to their environment in real time. Why make robots so human? What's the driving force behind this push for human-like design? They can go where it's too dangerous for people, places we simply can't risk sending humans. Like disaster zones, where conditions are unpredictable and potentially lethal, or hazardous environments, where exposure to toxins or radiation poses a significant threat. In healthcare, they could assist the elderly, providing companionship and support. or those with limited mobility, helping them regain independence and improve their quality of life. They can seamlessly integrate into our world, becoming a natural part of our daily routines. No need for special modifications, our homes and workplaces are already designed for human use. These robots use our tools, designed for human hands and human capabilities. They can open our doors, navigate the same entrances and exits we do, and navigate our spaces, moving through our homes and offices with ease. Of course, challenges remain. We're not quite there yet. Battery life, cost, these are significant hurdles that need to be overcome. And ethical questions about the role of robots in our society demand careful consideration. But the leap in capability is undeniable. The progress we've made in recent years is truly remarkable. This is a glimpse of a future where robots work alongside us, a future of collaboration and shared progress, not just in factories where they've already become indispensable, but in homes and communities, becoming integrated into the fabric of our daily lives. It's a huge step forward in robotics, a testament to human ingenuity and our relentless pursuit of innovation. The future is collaborative, a partnership between humans and machines. Let's keep going, pushing the boundaries of what's possible and shaping a better future for all. Robotics isn't just about legs and arms. Meet the spherical patrol robot. Designed for surveillance, these rolling sentinels can move in any direction, navigate crowds, and handle rough terrain. Packed with 360-degree cameras, thermal imaging, and sensors, they stream real-time data to law enforcement. They're not replacing officers but acting as force multipliers, patrolling autonomously, responding first to alarms, and enhancing situational awareness. Of course, this raises big questions about privacy and surveillance. Where do we draw the line? How is data used? These are debates we need to have. But from a tech perspective, it's a clever, resilient solution to public safety. Robotics is rolling into new territory. Getting to space is undeniably expensive, a barrier that has historically limited access to a select few. But Vortex Orbital Transport is challenging this paradigm with a radical idea: to launch rockets using a controlled, ground-based tornado of superheated gas. This innovative approach aims to redefine space access. Instead of relying solely on the immense power of traditional rocket engines, a ground-based vortex generator provides the launch vehicle with a massive initial boost, acting as a first stage. This reduces the required rocket size, weight, and overall launch cost significantly. Crucially, most of the energy needed for launch comes from the ground, potentially powered by sustainable sources like solar and wind, making launches not only cheaper but also environmentally greener and more sustainable. The entire system is designed for rapid, reusable launches, minimizing downtime between missions, potentially turning months of preparation into mere days or even hours. If it works, this innovative approach could revolutionize the way we deploy satellites and ultimately democratize access to space for a wider range of users. Of course, the engineering challenges are immense, but the potential payoff could be a fundamental and transformative shift in how we achieve orbit. It's a bold, disruptive vision for the future of space travel. Space is poised to become significantly more accessible than ever before. So let's see what groundbreaking technology is flying next. Imagine a drone the size of a mosquito. Microdrones are redefining what's possible at the smallest scale. These tiny flyers use piezoelectric muscles and custom microbatteries with onboard brains that manage flight in a world where air feels thick as syrup. Why go so small? Access. They can slip through cracks in disaster zones, gather intelligence discreetly, or monitor the environment without disturbing it. Swarms could measure air quality, pollinate crops, or study wildlife up close. The challenges are real: wind, battery life, and payload limits. But as the tech matures, these hurdles will shrink. Microdrones are opening up a new world of possibilities. It's microengineering with macro impact. The future is tiny and powerful. What if a drone was designed to crash? Meet the Flyability Helios, built inside a carbon fiber cage for industrial inspection. The cage absorbs impacts, letting the drone bounce off walls and obstacles in tight, hazardous spaces. It's a game changer for inspecting boilers, tanks, and nuclear facilities, places too dangerous for people. With HD and thermal cameras, it captures crucial data without shutting down operations or risking lives. It's not about replacing workers, but giving them safer, better tools. This is robotics solving real-world, dirty, and dangerous jobs. It saves time, money, and lives. Sometimes resilience is the most brilliant engineering of all. All this tech runs on computer chips, but Moore's law is hitting its limits. Enter next-generation microelectronics manufacturing, NGMM. pushing beyond silicon with new materials and 3D chip architectures. Stacking components vertically means faster, more efficient chips like building skyscrapers instead of single-story houses. Materials like gallium nitride and carbon nanotubes promise even greater leaps. This is the foundation for AI supercomputers and every device we use. It's deep, essential R&D that powers the future, the invisible engine behind every breakthrough. The next wave of innovation starts here. 3D printing has gone nano. Nanoscribe's 2-photon polymerization lets us print structures smaller than a human hair. A laser solidifies resin point by point, building intricate microstructures for medicine, optics, and beyond. Think custom microneedles for painless drug delivery, or scaffolds to help nerves regenerate. In optics, print microscopic lenses onto sensors for ultra-compact cameras and next-gen communications. This isn't just a new tool, it's a bridge between digital design and the microscopic world. Researchers can now build what was once only theoretical. It's a quantum leap for manufacturing, medicine, and science. The future is being printed, 1 nanometer at a time. Let's power up. Fusion power, the holy grail of clean energy, may finally be within reach. Commonwealth Fusion Systems with MIT and Google is using high-temperature superconducting magnets to build a compact, powerful fusion reactor. Google's AI helps simulate and optimize plasma behavior, speeding up development. The goal: Spark, the first device to achieve net energy gain from fusion, more energy out than in. If successful, it could pave the way for commercial fusion plants in the 2030s. This isn't science fiction, it's a real engineering project backed by serious investment. The potential? Virtually limitless carbon-free energy. Solving our energy and climate crises with one technology. It's one of the most important projects on the planet. The future of energy is heating up. Even legacy tech is getting smarter. The MH-60 Blackhawk is now a digital powerhouse. Miltech's upgrade adds advanced sensors, AI, and electronic warfare systems, giving crews unmatched situational awareness. AI fuses sensor data, identifies threats, and suggests flight paths, reducing pilot workload and boosting survivability. Stealth upgrades make it harder to detect, even in hostile environments. It's not about reinventing the helicopter, but supercharging a proven platform. This blend of old and new is a cost-effective way to stay ahead. The future of defense is smart, connected, and adaptive. Classic hardware, next-gen brains. There you have it, 10 technologies shaping our future, from deep space to nanoscale engineering. These aren't science fiction, they're real, being built and tested right now. Progress is happening everywhere, at every scale, and it's all connected. The choices we make today are building the world of tomorrow. Innovation is accelerating and the future is being built right now. It's an exciting, and slightly intimidating, time to be alive. I can't wait to see what comes next.